welcome to RagBrag, Finecone's new live stream event, where we talk with AI founders and engineers about the challenges building the next generation of AI software. I'm Valeria Gomez from Pinecone, and today we are joined by an incredible guest, Andrew Lee, co-founder and CEO at Shortwave. Andrew
Good
and his
morning.
team. Good morning, Andrew. How are you?
I'm doing great. How are you?
Doing great. I was gonna give you like a little intro there before we kick it off, but I just wanted to share with the audience that you and your team are truly on a mission to make everybody's email experience top notch. You guys are creating a product that really aligns seamlessly with the infrastructure email, and you guys believe that email is the backbone of modern business communications. But before we kick off our conversation, we are eager to hear from all of you tuning in live today. Please drop your questions and comments in the chat below, as we will be dedicating some time for Q&A at the end. Now, Andrew, officially welcome. We are very excited about this chat today.
Happy to be here. Thank you for having me.
Absolutely. So what about we just start with this conversation, kind of giving an overview what Shortwave is?
Sure. Shortwave is an AI-enhanced email app. We hook up to your Gmail account. It works with the existing account that you have, and we give you a different app for doing your email. And it does all the normal stuff you'd expect an email app to do. You can look at your inbox, you can label things, you can send emails, you can search, and all of that. But the thing that people use it for is we bring the full power of LLMs and other modern AI tech into your inbox to help you be more productive. And there's a bunch of things that we do, but I think the thing that people know us best for is we have a conversational agent that on the side of the inbox that you can talk to, and it can write emails for you. It can search your entire email history and answer questions. It can make summaries for you. It can schedule meetings. It can do all kinds of stuff. And it uses Pinecone for some of the features. I think the goal here is just really to make people more productive, especially people at work, people like you who are emailing people to get their jobs done.
I love that for sure. Everybody wants to be more productive, right? It's spending time where it actually matters. Andrew, we were talking the other day and I learned a little bit about you. So you have a very strong background in technology and startups, right? You founded Firebase, an app development platform, which you sold later to Google as you continue to work and grow the company there for 3 years. So, Shortwave, a productivity software, Firebase, very different. So I really need to ask you, what made you start Shortwave?
Yeah, this is a question I get a lot because it's very much not a developer product. It's a very different kind of product. And really, I think what it comes back to is I have a long history with email, and I'm weirdly very passionate about it. So in high school, actually, my dad and I ran an ISP in our basement, and we provided web hosting and email services and stuff to a bunch of other people. And I got very familiar with how the email protocols worked and the really cool aspects of this federated infrastructure that underpins email. I think a lot of people don't realize that unlike every other tool that you have for chatting on your phone with other people, email is not a single service from a single company. It is a network of servers that all communicate over this shared protocol. And that gives you a couple of really amazing benefits. One of them is interop. You don't have to get everybody, you and I are on Zoom, but if you were on some other service, we'd all have to agree on the same app to use. But with email, you don't have to agree to use the same app. I can use Shortwave, you can use whatever you want, and it all works together seamlessly. And the other really cool benefit is a governance benefit of if you're someone who really cares about your privacy and your data, you can run your own servers and you can have full control of that stuff. That's really important for if you're a big multinational or you're a political activist or you're just someone who cares a lot about your privacy, you can do that. And I thought these aspects of email were really awesome. And I felt like the companies that were building email clients were not doing justice to this amazing infrastructure under the hood. And so we started actually before AI really got to the point that it is today. We started this in 2020, and we spent the first couple of years just building out the core of what is an email client? How do we thread your emails and display your emails and help you compose beautiful emails and send those emails and label and search and all of that? But a couple of years in, we started noticing that, hey, this LLM tech is getting really good, right? And suddenly it's gone from a fun demo and a science project to something we could build a real product on. And we've gone just totally all in on that. So that's been a bit of a pivot, but we are at this point like fully focused on how do we bring this amazing technology to bear on your email and make it really good.
Absolutely. I think I didn't realize that email didn't change that much. It has been like the same since I started using, email for so long. So I'm glad that you are disrupting the field to make us more productive and really get the most out of email. Andrew, so in September last year, you guys launched the Shortwave AI system, right? And since then, your team has been so busy launching a ton of new AI stuff. So far, I think for the first 2 months of 2024, you have had 5, correct me if I'm wrong, 5 major releases. So with what you just explained, the reason why you decided to embark on this journey with Shortwave, I want to know, why are you making this huge bet on AI as a company?
Yeah, I just think it's going to change everything. If you look at my personal email usage today, the majority of my emails have some AI generated text in them at this point. Most of the calendar invitations that I create and send are created by an AI assistant. A significant fraction of all the searches I run are helped by AI. I read summaries of emails before I send the emails. I, converse with people in other languages through translation. So I've been seeing my own usage of this change and the power of this stuff. I've been seeing this happen in a lot of other industries of AI is just totally transforming how stuff works. And I think either we do this or we become irrelevant. And I think the same is true of everyone else too. I think it is a must-win transition. You've got to figure out how to do this. You've got to make this transition. And I'm also just really excited about it. It's really cool, the stuff it can do. And one of the things I discovered when I started Shortwave is that I am an extreme email power user. Like no one emails like I do. I send more emails. I get and read more emails. I organize more emails than just about anyone. And AI has helped me tremendously do that. I can respond faster to things. I spend less time in my inbox. I feel less overwhelmed. So it's got me pumped.
Absolutely. I mean, everybody uses email in one way or another every single day. So why not make it better? And since you touched on some of the things that you can do with Shortwave in your email, right? So what about if you share with us what is your favorite Shortwave feature?
Yeah, this is actually one of the new ones we launched just a few weeks ago. It's called AI Autocomplete, and you can think of it as GitHub Copilot, but for your email. And just as you're typing, it'll give you suggestions, and you can do completions. And there are other versions of this you can use. iOS has like a built-in one that's like giving you like very short suggestions. But the big difference with our autocomplete and everyone else that's doing this sort of thing in the inbox is we're basing this off of your emails. Everyone else is like taking an LLM and they're predicting the next couple of words based on like what humans normally do in that context. But we're actually saying, what emails have you sent in the past? What have you said in these situations? How can we predict that? And this lets us do a couple of things. One is we'll use phrases that you would actually use. Like you'll be typing along and you're like, that's what I say. And it's not like a generic thing. And the other thing we can do is we can actually pull up facts for you. So, as an example, when I'm inviting people to come by our office, we have an office in San Francisco. I just say, stop by our office at, and it autocompletes the address, right? And then, I say, if you have trouble getting in, call me at, and it autocompletes my phone number because it's seen those before and it can complete those. And I think the great thing about just like GitHub Copilot is the form factor of just being autocomplete, like fits into my workflow really nicely. And so just I don't really have to change my behavior. I'm still writing emails the way I normally do, but it keys off of the first few things that I type and figures out what's next and just makes every email I write a little bit faster. And it makes it so that I don't have to like run searches as much while I'm typing to look things up because it can look those up for me like as I go.
That's really, really cool. And I love the tagline that you guys are using for this feature that is AI autocomplete finishes your sentences so you don't have to. So it seems like everybody can do that now and everybody should benefit from it. Since you touch a little bit more of, how the autocomplete works, maybe can we go a little bit deeper into that and maybe you can share from the product perspective and how Shortwave autocomplete works.
Yeah, and this is one of the features where we use Pinecone, and one of the reasons why it's so fast is that Pinecone helps us stay really fast. And I legitimately love Pinecone. That's why I'm on here, and it's helping us build this feature. But basically, the way it works is, as you're typing, we are constantly running two searches, and these are searches of embeddings that we have generated in the past that we've stored in Pinecone. So these are vector searches. The first search is find me emails that you have sent that are in response to similar threads. So basically we say, hey, the last time the user responded to something like this, these are the things that they said. The other search we're running is find me things that you have sent that are similar to what you've typed so far. So basically saying, hey, the last time the user started an email with, unfortunately, what did they say? And we take those two sets of results and we pull those into a prompt, and we feed that off to a model that we fine-tuned, and it produces a completion that's somewhere between like half a sentence and a sentence to kind of like keep you going along. And we do that all really fast, and we try to do it in a way that sort of doesn't get in the way, just so you can like type the way you normally would, and it helps you out as you go.
That's so cool. So it seems that all of these AI suggestions are intelligent, right? And they're based from previous emails that the user has sent, and he also kind of uses facts. So it sounds like the user, right? So you just mentioned that you use Pinecone for part of that, but any other AI stack that you are using to kind of power this autocomplete to make sure it does what it needs to do?
Yeah, so the model in this case, we actually use 6 different LLMs in our product. 3 of those are ones that they're open source models that we run on our own GPUs, and then 3 of those are ones from OpenAI. This particular feature is powered by a fine-tuned version of GPT-3.5, and that is the extent of the AI. Pinecone plus GPT-3.5 plus a bunch of traditional infrastructure is kind of what makes it work in real time. But before we get to any of this, there's also embeddings that we have to generate beforehand. So every time you send an email or every time you receive an email, we're actually also taking a different open source model on our own GPUs, and we are embedding your emails. We're storing those in Pinecone to be ready to run those searches at the right time.
Wow. So a lot goes into building AI products. So there's like so many moving pieces, so many pieces of technology to make sure that, it works. But what is very unique about you, Andrew, is that you have been a founder, right? Not just once, but twice. But you also are an engineer. So you bring 2 different perspectives and kind of this journey of kind of building a product to life. So maybe you can share with us what has been your biggest challenge while building the Shortwave AI system, or maybe not just your challenge, but what has been the biggest technical challenge that your team has faced?
Yeah, I think there's a few here. So early on, I think we figured out that the base models that you can get sort of off the shelf now, things like GPT-4, are smart enough to produce some really valuable output if you can get the right data into the prompt and you can explain it to the LLM the right way. And that's caused us to think internally about all of our tech here is how do we get the right data into the prompt at the right time, and how do we explain it to the LLM the right way? And so a lot of the challenges actually come down to retrieval, and if you want to step up to a higher level, it's how do we do retrieval in such a way where, this whole system comes together to give you something that feels reliable, that a user can use, and it feels deterministic, and it feels like it knows everything, even though it is, a Rube Goldberg machine that's been duct taped together with a bunch of LLMs that are like not particularly deterministic, and they hallucinate. And like, how do you turn this whole thing into a thing that like feels solid? And I think that's been a real challenge. And it's been a combination of a lot of things that make that happen. So I'll give you an example here. So on the search side, we use Pinecone for semantic retrieval. Like we say, hey, the user is asking us this question. find documents that are semantically similar to the question or to a document that we generate in response to the question. And that technique actually works well in many cases. Often the document that answers your question is going to be similar to the question that's being asked, or you can like figure out what the document is from the question that's being asked, and then do a semantic similarity search. But often there are questions where the document that answered it is not semantically similar to the question. It's hard to predict what that thing is. And for that, we use a bunch of other infrastructure to run searches. So when you're asking us a question, we run searches in Pinecone, and a lot of times the answers come from Pinecone, but we're also running a whole bunch of other searches in much more traditional infrastructure. So we're doing keyword searches, and we're looking for date ranges, and we're looking for labels, and we're looking for contacts, and like a bunch of other things. And we combine the results of those traditional searches and the semantic searches, and we do a re-ranking phase. And then after that, we have a whole bunch of heuristics that we run to account for things that, basically things that we ran into empirically in production. So I'll give you an example. One of them is recency bias. If you ask, how much did my flight to Los Angeles cost? You might have 10 flights to Los Angeles in your email history. The one you're talking about is probably the most recent one, but that isn't inherently obvious to your retrieval system. And so you have to kind of build that in as a heuristic, be like, okay, let's weight the more recent ones more highly. So this whole system, when you ask a question, it's not quite as simple as, run retrieval, take the results and put them into the prompt. It is run retrieval across many different systems of many different types, re-rank those, apply a whole bunch of heuristics on top of that, and then feed that into an LLM and get a response. And then that's not even all, because after you've done that, you get back this raw output from the LLM, which isn't necessarily beautiful or useful. Like you want to have like a button to like insert into your email, and you want to have certain things formatted. And if you're creating a calendar invite, you want it to like show it as a calendar invite. So we have a whole step after the LLM gives its output to like turn that into a thing that like looks nice and can do things. And there's a lot of rules and heuristics in there as well. So it is, if you look under the hood, just like, it looks like a car engine. You pop the thing open and you think it's going to be beautiful, and it's just like cables and wires everywhere packing into this thing. But at the end of the day, when you press the gas, it goes, and we want to hide all that complexity from the user. So yeah, just the challenge of like building a reliable system from unreliable parts, and especially how do we make retrieval feel that way? I think another big challenge that we run into is cost. It is very expensive to do what we do. And there's a lot of pieces. So embedding emails is expensive. You need a lot of horsepower to do it. Storing vectors is expensive. We have a lot of vectors, and this is especially painful for us because a power user, email user, can have millions of emails in their inbox. I have 3 million emails in my personal inbox, and you have to have a lot of vectors, and how do you store those efficiently? So I think that's been a challenge as well. The calls to GPT-4 are very expensive when we do those. Our autocomplete, we're making LLM calls, constantly, like every few keystrokes, we're like hitting an LLM. So cost has been a big factor for us as well. And all of these, there's no silver bullet, there's no magic answer. It's just like a lot of detailed work.
For sure. It's like so many moving pieces to make this work. And, I'm glad that you touch on those challenges, especially like cost, right? A lot of people can relate with that. Any more insights that you have around that, like how to kind of optimize costs for like a startup of your age? Any more that we can go around there?
I don't know that I have a terribly great summarized version of how to optimize costs, but I do think it's useful to share how we're thinking about this. And one of the assumptions that we are making is that the cost of these technologies is going to come down dramatically. And I think you've already seen that just over the life cycle of our AI assistant, which is like less than 6 months old. GPT-4 Turbo came out, and that dropped the costs on the generation side there substantially. Pinecone's come out with this serverless offering, which it's not available on GCP yet. We're hoping it will be soon, but that'll help, I think, on that side as well. There's new embedding models out there. So I think if you build a product that is, losing some money today, not losing so much you go bankrupt, but losing some money today, 6 months from now, you'll be breaking even. A year from now, you'll be making money. 5 years from now, you'll have great margins. So I think I would factor that into your business plans of you probably want to be, if you're focused on AI right now, you probably want to be burning a little bit of money to get the best stuff and make sure you're building the right product, and count on those cost curves to come down.
Absolutely. And technology is changing very, very fast. So, hopefully these kind of costs are going to also go down as, technology changes. So I kind of want to bring us back to one of the challenges. And, one of the things that we keep hearing is this challenge about building knowledgeable AI products, right? While significantly reducing hallucinations. That's a big problem, right? When you start kind of using customers' data and trying to kind of give predictions and suggestions. So maybe you can talk a little bit more what kind of techniques your team is using to make sure that you're building a smart and knowledgeable email product.
Yeah. Hallucinations are tough.
Yeah.
I have found that the best quick tool to reduce hallucinations is just better prompting. If the AI says something crazy, you just tell it in the prompt, you don't know this, or if they ask this, don't respond, or don't respond to things if you're not sure, those kinds of things. That is very finicky, but you can test it. So we have a bunch of in-house testing infrastructure, like test prompts, and we'll test out a whole bunch of different questions, and we'll tweak the prompt until we get the answers that we want. It's not perfect yet. Another thing that we do is we build features around hallucination. So I'll give you an example here.
Yes. Wow.
We let you create calendar invites through the AI assistant. You can go to the AI assistant, and you can say, make a calendar invite. And it works great, actually. This is one of my favorite features now. We didn't have this initially. We had the ability to look up information from your calendar so that while you were composing, you could insert stuff, but we didn't have a way to make a calendar invite. And people started asking the assistant, make a calendar invite for me. And it would say, aye, Captain. And it would claim that it did it. It'd be like, great, I created a calendar invite for you, even though it didn't have that capability. And then email us to be like, hey, the AI assistant said it made a calendar invite and it never showed up in my calendar. And we got a whole bunch of these. And we're like, oh, I guess people want this feature. Rather than letting the AI assistant hallucinate that it's made a calendar invite, let's just build that feature. And now that's gone, right? People, it no longer hallucinates because those responses are accurate. And we're actually creating a calendar invite for them. And I think we're going to keep doing that sort of thing. So as we get complaints of, hey, I asked you to do X and it gave me some wonky answer, if we get enough of those, we'll be like, we're just gonna support that use case and make it work well.
For sure, we need to teach the system to think, right? And kind of going back a little bit, you were talking about retrieval, right, as core of the product. So maybe you can share a little bit more about how you use, I guess, RAG to make sure these products are, smart and knowledgeable. Maybe how you have approached these, or any point of view, or anybody out there trying to figure out how to build these knowledgeable applications using RAG.
Yeah, I think there's a few things to consider. So the first is what I mentioned earlier about RAG is useful for looking up certain types of information. So anything where you're looking for semantic similarity, either with the question or with a hide based embedding that you generate, and that can help you in many cases. But there's other cases you may need to consider for your application that I think are worth thinking about. And a couple of those that come to mind for us are that we run into is one, there may be metadata-based queries where people are saying, they might ask, how much was my flight to Los Angeles? Or they might ask, well, how much was my flight to Los Angeles last year? And or how much was my flight to Los Angeles in February of 2019 or something? And in those cases, the vector search might return, a lot of results, might have trouble finding the thing that you're looking for. But if you can also include the metadata in there and search for things that happened in February, or combine those two together and say, let's search for things in February that are also semantically similar, you can get a lot farther. So I would say first thing to consider is how does RAG fit into your overall search system? How does it work with traditional infrastructure? How do you make that all work together? So that's my first thought. The second thought I have is there are some trade-offs that you really want to consider between basically cost of embedding, cost of your vector database, and performance of the system, and speed of answer. All four of those things are fundamentally traded off. And I'll give you some examples here. So if you if you want the best possible results from your retrieval system, the thing to do is create a big vector. Like you use an embedding model, like you use, the best one that OpenAI has, you make a big embedding model. That is slow, which maybe you don't care if you're doing it at ingestion time. Maybe it's not a thing you care if it happens real time, but it's slow. It could be very expensive. It would have cost us a lot more, like 20x more, to do what we were doing through OpenAI that use the open source models that we do. So it could be prohibitively expensive for you to do it. But it might give you better answers. But it's also going to drive up the cost of your vector database. So the bigger your vector, the more data that Pinecone has to store, the more it's going to cost you. And so you may not want to go with the best embedding. We don't. We go with a smaller embedding that is cheaper to generate, that uses less storage in the vector database. And on the other side of that, when we're running retrieval, we compensate for that basically by just like retrieving more vectors and then running another model to do re-ranking on those. So the accuracy of our retrieval is lower than it could be, but what we're trading off is we have GPUs on the other side of that we think are cheaper than paying for the embeddings themselves, and we're willing to put up a little bit more latency on that as well. And I think the trade-offs that you make here are going to be different for different applications, right? Like some of them you may care a ton more about accuracy, and you don't care so much about the cost of it. Other cases, you may say, what I really need is performance on retrieval side. So I'll give you an example here. For AI question answering, if it takes a few seconds to answer the question, it's a pain, but it's not that bad. For AI autocomplete, it wouldn't work, right? It's got to be really fast.
Right away.
For AI autocomplete, we don't use our re-ranker. We just use retrieval. And the reason that actually still works, even with our smaller embeddings, is we're only doing retrieval on your sent emails, which is a much smaller corpus than like the overall system. And so, yeah, I would think through, what are my performance requirements? What are my cost requirements? How many vectors do I have? So not just cost of embedding, but the cost of storage of those things. How good does the quality have to be? And think about all those things. I would also be thinking about the trends in embeddings. Like the embedding models are just getting better and better and better. And like, if you find like you can't get quite where you are right now, you might find in 6 months that you can grab something off the shelf that just does that for you.
It really comes down to your AI strategy, and particularly on your use case. And also it sounds that it depends on the also individual kind of AI features that your product has, right? Not everything has to have the same technique. And so you really need to figure it out, what is best for that particular use case. I love that. Andrew, we have covered different topics today, from your vision on AI, your favorite shortwave AI feature, autocomplete now is going to become mine too, the role of RAG in generative AI, and also all these techniques, like the challenges with building these AI products, and kind of switching a little bit away from, the product, but more about on the field, and just kind of why you started at Shortwave. Where do you think the next big leap in productivity in AI software is going to come from?
You mean specifically in software development?
Yes, in software development, yes.
That's a great question. I think the models that we have today are really sort of designed to run ChatGPT or ChatGPT-like systems, and they, if what you're trying to do is like a conversational Q&A thing, I think they work pretty well. We've struggled a lot to plug them into sort of the inner workings of a system where like they're making decisions that are maybe not user visible, but like are doing things inside your system. And, as an example, like we have a lot of code to parse the text that's spit out by these LLMs, which feels very inefficient, right? The LLM internally isn't working in text, it's working in these, weights and like much more computery sort of data, and it's turning back into text, and we're parsing text, and that feels off. And so I think there will be much better technologies and models and things for running agents where the inputs and outputs of the LLMs are not humans, but is actually like making the software work fundamentally. It's making decisions for you, and it's, prioritizing things and categorizing things but with the same level of intelligence. So I think there's gonna be a lot of developments there. I'm excited about that. I think there's going to be higher level retrieval stacks that come out. So I think, Pinecone is, as it is today, is awesome if you want to drop down to the level of, generating the embeddings yourself. But there's open source, for example, like you can use Llama Index, right? To say, rather than me building the whole system myself, I can use Llama Index and I can run, have HIT figure out how to turn that into a Q&A system for me. And I'm still using Pinecone for the retrieval, but it's putting together with other pieces. So you may not need to build the full stack retrieval system yourself. You may be able to rely on something a little bit more off the shelf to do that sort of thing. So I would keep an eye out for that. Do you need to build a full system yourself, or you can use an open source product? I think open source models are going to get better. We've already seen this. So we're using Mistral for some of our stuff, and it's awesome, and it's on our own infrastructure, which is cheaper, and we get latency benefits and we get privacy benefits. So I keep an eye on that as well. Lots of cool stuff coming.
Yes, for sure. The AI stack is really changing, and there is so many other providers, many moving pieces that are now available for AI founders and engineers trying to build really cool AI products. So we are almost at time, and before we spend some time for Q&A, I would like to kind of end this portion of the conversation with some words of wisdom from you, more than what you just had given us. Maybe some tips and tricks for the audience. So maybe, do you have any recommendations for those out there currently thinking about investing in AI, or those that are not thinking of prioritizing AI right now for the companies or the products?
Yeah, I think my first suggestion is definitely take a really hard look at AI. I think there are very, very few areas in technology that are not going to be just radically changed by what is becoming possible here. And you either need to become aware of it and do something about it, or your product will quickly fall behind what other people can do. And if you're starting something new, there's opportunity there, right? If the incumbents are too slow to take advantage of this stuff, and you can build something cooler and better, I think you'll have a pretty awesome growth trajectory as a result of that. So I think that's my first thought. As far as actually building things with AI, my suggestion would be, I think a lot of people fall in the trap of trying to, build more things than they have to, optimize more things than they have to. And the technology, the basics of the technology are getting better so much faster. The vector databases are getting better, and the models are getting better, and the services on top of them are getting better, where you can sort of count on the building blocks that you're using to get better dramatically over time. And so if you're not someone who's building one of those core technologies, focus on the end user experience and use whatever expensive thing you have to do it. So if you're prototyping, start with GPT-4, or whatever the latest and greatest thing is at the time. It might, a week from now, that might be something else, right?
Something,
the best model you can. Don't do any fine tuning. Don't do any cost optimization. Just prompting with an expensive model. Make the basics of the thing work. Prove out that this is going to work with your users, and then figure out how you make it fast and how you make it cheap and how you make it scalable and all of those things. But I would very much start there. If you can't make it work with the most expensive, the best model out there, or if the users don't love it, great, you've saved yourself some time. There's no point in trying to build the rest of those systems.
Oh, thank you so much for sharing these insights, Andrew. I really hope the audience can take these, recommendations from your experience and really apply them to their strategies when thinking about building AI products. So I see a lot of questions coming in the section. Should we address some of those now?
Let's do it.
Okay, I'm gonna turn here around and let me see. I need to scroll, so just bear with me. Let's just start from the beginning. See, some people are just giving you some shout outs, Andrew. I can confirm Andrew emails a lot. There go. Thank you, Andrew. We have here actually a question from Michael. He is asking how you distribute tasks between all of these models.
Yeah, so we have 6 different models that we're running right now, and I'll just kind of walk through what each one of them is and what they do. So we use GPT-4 Turbo for the final output in the AI assistant. So if you log into our product and you talk to the assistant on the side, the actual text that's being outputted in that assistant pane is coming from GPT-4 Turbo. And we're using Turbo because it's faster, cheaper. We're using GPT-4 because it produces the highest quality results. And like, we think the thing that faces the user is worth spending that money on. We use GPT-3.5 Turbo for a few of the smaller features that you run into in the UI where we don't necessarily need the full power of GPT-4. So for example, when you do forwards, we give you we can add a summary to the top of the forward before you send it that lets the recipient get a gist of what the forward is. It's actually a really cool feature, but that's a GPT-3.5 thing. We don't need any special fine tuning there. We don't need to spend on GPT-4. We use a fine-tuned version of GPT-3.5 Turbo for the autocomplete. And there we need the performance, but we also need it to have like good intuition about like how much to complete and the phrasing of those completions, and like it needs to sound like email, stuff like that. So we tried just a straight GPT-3.5, wasn't at the bar, but with the right fine tuning, we were able to make that work. So those are all the OpenAI things we use on our own GPUs. And by the way, one of the things that we divide is like we only use OpenAI for active features. So people who choose not to use our AI features, nothing ever goes over to OpenAI. We only send stuff if you like do an AI thing. For all of the passive features, we use stuff on our own GPUs in-house. And we use three models. We have an embedding model that we use for at ingestion time. We embed and save the embeddings for your emails as they come in so we can do retrieval. We're using a model called InstructorXL for that. It's just an open source model. We use a cross-encoding model for re-ranking. It's an open source model based off a Microsoft data set they put out a while back. And that's for, when we do retrieval and you do your semantic search and you do your keyword search and your label search and all that, and you put that together, we have to find some ordering to figure out which things to actually pick. And that's what that cross-encoding model is for. And then finally, we use Mistral, also on our own GPUs. And we use that for the instant summaries that we produce. So when you open up an email, there's a summary that comes at the top. We're going to use that for a lot of other things going forward. I think I've been very impressed with Mistral. It's fast, it's good, it's cheap. You can run it yourself. So yeah, those are the 6 that we use.
Amazing. Hopefully this answers Michael's questions. Let's go on, and I see one here from Roberto. Roberto is asking how you make your LLMs evaluations.
It is not terribly scientific. We have tried lots of different techniques here, and really what it comes down to is like, you got to come up with a test data set of real questions that you might ask and real data sets and real answers. And like, you kind of look at the results, and you can automate this to some extent. Like you can have an LLM like evaluate the results and see if they're good. But honestly, like we've been moving so quickly, and the only thing that really made sense for us is to human intuition here. So it's been make a data set, run the data set on, the LLM, read the output, see which one feels best. Like as an example with our instant summaries, we tested stock Mistral and then a bunch of fine-tuned variants of Mistral. And it was just, basically the engineer emailed the team and they're like, here's 10 threads and 10 summaries. Choose A, B, C, D. Which one seems best to you? And like, we picked the one that seemed the best there.
Awesome. Thank you for answering that. And we have another one. Is from Mary. Mary is curious if you have considered using knowledge graph types of functionality, perhaps to reduce hallucinations.
We have. We haven't built anything here specifically yet because I think it would be really hard to build a knowledge graph that like fully understood all the stuff going on in your email. So I think there's probably opportunity here, but the complexity of the ideas that are expressed in your email, all the things going on, I think would make it tough to do this generically. We might do this for certain types of things. Like we might do this for like contacts, for example, where it's like we try to reduce hallucination around contacts. We know a lot about those and construct those. But short answer is not yet.
Okay, that's fine. We have another question, and Cher is asking, how do you combine results from keyword systems and semantic systems and rank them? Are you doing this combination at the application layer, or do you use a hybrid search from Pinecone?
Yeah, so we're doing this at the application layer. We have actually been testing hybrid search recently, although it's something that we've kind of put together on our side, and it does seem to help, although not as much as we were expecting. But the production version of this right now it's all our own code, it's all our own stuff. It's a combination of a bunch of heuristics that are based on our understanding of how email works, and then this cross-encoding model that we run for re-ranking. And it's complicated. If you're looking at doing this sort of thing, I would go check out. There's a project called Colbert that we've been looking into as well. That can be used. There's some tech in there that can be used as a re-ranker. So I think that's worth checking out. And then I think hybrid search is also a good thing to explore. We're looking into it more right now.
And we have a follow-up question about evaluations. So Jorge wants to know, if you don't have evals, how do you keep any quality control? Do you have any reporting to measure how the Gen AI features are performing, or the clients complaining about it?
Yeah, it's a very lightweight process. So I should mention that we are a relatively early stage company, and things are changing very quickly. So we are optimizing for speed in everything we do, but we do have two main customer feedback mechanisms. One is we have like a thumbs up, thumbs down in every question, and we monitor like how many people are thumbs up, they can thumbs downing, and like when we roll out new things, how does that affect that? And the other thing is there is a provide feedback button at the bottom of the assistant. Every time you get an answer, you can send us not just a thumbs up, thumbs down, but you can actually give us some textual feedback on what we're doing. And we get a ton of emails every day. Those feed into email. We're an email company. Everything at Shortwave is an email. But we get a ton of emails every day through that of just textual notes about, I tried this question, I got this answer, it wasn't what I expected, here's why. And we're just reviewing those. There's probably a lot more we'll do in the future as we really like tune this stuff. But right now at that, binary thumbs up, thumbs down, plus the textual feedback is like more than we can process right now. So it seems like a good amount.
Great. Thank you for answering that for Jorge. I think we have time for one more question, and this comes from Telasi. He wants to know, do you create a separate index for each user in Pinecone?
So this is a great softball for Pinecone. So I'll tell you all why we use Pinecone. It's great at a lot of things, but there are a lot of vector databases out there, and everything but Pinecone, we evaluated a whole bunch of them, and everything but Pinecone, if you have a lot of users and you run a query, the search in the vector space is going to have to search through a whole bunch of users, and the way you filter down to the documents from that one user is by post filtering after you do the semantic similarity search, and that's really slow if you have a lot of users. And Pinecone gives us namespacing, so we can say, hey, we just have a whole bunch of users, treat each one of these totally independently, and only do the vector similarity search within that namespace. And that has been really critical to performance when you have a huge number of users, and each of those users has a huge number of documents. And no one else has an implementation that is built in this way where you get that performance. You can do the same, like you can use like pgvector and you can get the same thing, but the performance starts to degrade at scale when you have a lot of users and a lot of vectors. So that's the killer feature right now from Pinecone, is namespacing for us.
Well, I'm glad you're using, and thank you so much for the chat out there. We are almost at time. We are running out of time right now, but Andrew, it has been a pleasure chatting with you today, learning about your journey, about Shortwave, about the incredible AI features that you guys are building. If people want to connect with you, if they want to kind of continue the conversation, if they want to learn about Shortwave or even try Shortwave, how they can get in touch with you?
Email me, andrew@shortwave.com.
Amazing. Well, Andrew@shortwave.com. There you go. So we are out of time right now. Thank you for listening and joining us live today. We'll be here again next month, chatting with AI founders and engineers about the amazing AI products they are creating. With that, we will chat very again soon.